Now let us look at a second procedure for finding duplicates in a sorted array. Already I have a sorted array and there are some duplicate elements like 8 is duplicated and 15 is duplicated. We want to know how many duplicates are there, and also we want to know count. Like if 8 is duplicated, how many times it is duplicated? If 15 is duplicated, then how many times it is duplicated? Now for this second method, I am using hash table. So this is the simple form of hash table, right? Though we don't know what is hashing, we have it in the last section, but just we are using a simple form of it. So this is an array actually, and the array size is 20. Why I have taken array size as 20? Because the largest element in this array is 20. So just you can go at the end of a list because it's a sorted. So the last element gives you the size of this array. We should have an array equal to that size. So if it is 20, I must have an index 20. Remember this. So I should create an array of size 21, right? Then I get the starting index as 0 and the last index as 20. Then next, this should be filled with zeros. Yes. Then what is the procedure? Let us look at the procedure. So let us scan through this array by taking one element at a time. So for that, I will take a index pointer, that is I, starting from here. Now while scanning, check the element. Element is 3. So here, go to index 3 and mark it as 1. Increment it, right? Then move I to the next element, go to index 6 and mark it as 1. See, going to the index 6 and mark it as 1 takes just constant time. I have to say h of 6 plus plus. That's it. It's simple. Then go to the next element, 8, mark it as 1, increment it, right? The next, increment it. So actually this was 0, so I have marked it as 1. Now again 8 means make it as 2, increment it. Then 10, increment this one. Then 12, increment this one. 15, increment. So again 15, so make it as 2. Again 15, so make it as 3. So finally I wrote 3. Then 20, make it as 1, increment it. So scan through this array of n elements once and mark these or increment the count, right? So now in the hash table you can find that which element is appearing for how many times. So here we got the results. Now before showing in the code, let us do some analysis. How much work we are doing? We are doing nothing but scanning through this array. So how much? N, right? Then how many times? Only one time we are scanning. Then where is the result? And while scanning, we are marking this, that is incrementing the counts. How much time this is taking? Like for 10, I directly went to index 10 and I have incremented. Like for 15, I directly went to index 15 and incremented. So incrementing this take constant time. So what is the major time we have spent? N, accessing this one. Then next what we have done? We have to find out what are the duplicate elements from this hash table. So we can scan through this one. This is not there, not there. This is 1 time. Okay, 1 time. This is 2 times. Then this is 3 times. So I have to scan through this array also. How much time it takes? Plus n. How it is n? See, that are only 10 elements. These are 21 elements. So 10 means here not count. See, when we say n is the size of the input, n means size of the input to an algorithm, right? So in this procedure, n is the size. Okay, whose size? This size or this size? Whatever it may be, we are not bothered about exact figures. Here, now listen carefully, n means linear. Yes. Then what about this? Linear only. So what I should say? N only. If you say no, this is larger, okay, you take it as 2 times of n, no problem. No, still larger. So whatever you want, you write down k of n. So this is also linear. Then if I take it as only n, then I say 2n. So what is 2n? 2n is also linear, right? So finally it is order of n. Yes, it takes order of n time. So this is the analysis. Now I will write down the procedure and show you how we can mark these elements or count them and also display the result. So the procedure is I have to scan through this array. So for that I will take a for loop. For I assign 0, I should go till n, suppose number of elements are n, then I plus plus. Then for each element, like a of I is what? 3. So for a of I, right? A of I means, let us say, 3. So I should go to third index. So that is h of a of I. Yes, a of I is 3. So that 3 I should find the index here, right? So h of 3 plus plus, this will increment. So that's all. This is how I can mark them or increment them. This is over. Now the next step is go through this hash table array, and wherever we have count more than 1, print the element. So here for loop once again. For again I will take I. See, this is not inside this for loop. This is independent for loop, right? For I assign 0, I is less than whatever the maximum number is. So less than, or I is less than or equal to whatever the maximum number is. Like here we have maximum is 20, so up to 20, and I plus plus. What we should do every time, if that value here, the value is greater than 1, if h of I is greater than 1, then we will print. So in the same line I will write on printf. Here printf percentile d I gives the number, and h of I gives the count, how many times it is appearing. That's it. It's a simple procedure. Let us do the analysis. See, this for loop is repeating for some number of times, so it is n. And this is independent for loop. It's not a part of that one. See, this for loop was n. Now this is independent for loop, and it's also repeating for some number of times, so it is n. So when you have a single for loop, it is n. If you have for loop inside for loop, then it's n square. So this is n plus n. So this is 2n, and time is order of n, right? Or big O of n. So the time is order of n, or big O of n. So we have done the analysis from the code also. So that's all. Finding duplicates and counting how many times it is duplicated. You can write on this procedure. You can write a simple program, take an array and one more array for hash table, and write on this code and see, right? So it's a student exercise. That's it.